Hey guys, today we are looking at the problem longest palindromic subsequence. Okay, so the problem statement is fairly simple. What you have to do is you have to find a subsequence in a string, okay, which is palindromic, and yes, it's longest. Okay, so you have to find the longest possible palindromic subsequence. Okay, so for those of you who are confused about what subsequence is, how it's different from, let's say, substring, it's basically a part of the string. Okay, and the order matters. Basically, in a subsequence, it's the order is same, but it can be discontinuous. Okay, so that's the point of subsequences. The order is same, but it can be discontinuous. For example, this string BBAB. Okay, so subsequence can be BB. Then I can skip these two B and A and then write B. So it's a subsequence, right? I can't change the order, right? And it can be discontinuous, so we can skip a few characters if we like. Okay, so that's what you have to find. Longest palindromic subsequence. Now, of course, it looks quite intimidating as a problem, but it's actually very easy if you know LCS. Okay, longest common subsequence. It's actually based on this problem of longest common subsequence. Okay, let's try to understand how. Now, so what I'm going to do is basically break down this problem into LCS, which we already know, and then we can easily solve this problem. Okay, and that's what you have to keep in mind whenever you are doing TP problems, especially. It's valid across a wide array of data structures, but especially in DP, a lot of questions are derived from a parent question. Okay, that's why if you have mastery over a parent question like LCS, you can solve other questions pretty easily. Okay, so let's try to understand this problem once. Okay, so you have this string, let's say B B B A B. Okay, I have to find palindrome, right? What is palindrome? Palindrome says that if I reverse this, that means B A B B B. These should be same. If the entire string is palindrome, then if I reverse it, it's going to be same. Okay, what will happen if I apply LCS between these two strings? That means string s and reverse of string s. What will happen if I apply uh, LCS over it? It will find the longest common subsequence. So what's going to be the longest common subsequence in this? If you see, it's actually going to be BB BB, right? Right. So LCS between these two is this. Okay, right? Cool. Can I say that this itself is longest palindromic subsequence? No, it's a bit a weird thing to grasp, but think about it. What you did, you took the same string, you reversed it, and then you found the common part, right? So, why that part is still common? Because when you reverse it, it can still remain the same, right? So, if you reverse a subsequence, it still is same, it still is common. It means it's palindromic by nature, right? That's why. So, all you have to do is basically take this string, reverse it, and then find LCS. Okay, so there's few steps to the problem. So first step is to actually reverse the string, reverse s1, pretty easy. Reverse s1. Then what you have to do is find LCS between s and s reverse. Okay, basically that's it. And then You can just return that answer. Okay, pretty easy. Let's try to code it in Java. First, I'll just write the memoize solution. Sorry, not memoize. I'll just write the tabulation solution of LCS. It's okay. So let's do it. Um, the n is going to be s1 dot length, right? And then I'll create a matrix. Okay, let's call it dp of size n plus 1, right? And n plus 1. Okay, let's initialize it. Okay, it's all LCS now. I'm not doing any new question. It's all LCS. And I is equals to 0, I less than n plus 1, I plus plus. Similarly for int j is equals to 0, j is less than 1. Okay, I'm just initializing everything with 0. Okay, then what I have to do is simple. Int I is equals to 0. Sorry, I'll start from 1 now. I is less than n plus 1 and go I plus plus for again same thing. Okay, now how LCS works. So in LCS you basically have only two cases. Okay, if both of if I and j, okay, so I represents string s and s1 and j represents characters in s2, right? If both of them are equal, if both of them are equal, then what we do, we increment the count. Okay, we increment the count. So that's the first condition, that if my okay, let's take let's make that string first. I don't even have that string. String s2, let's call it s2. It's equal to string new string builder, new string builder s1 dot reverse dot string. Okay, basically using a string builder, initializing the string, reversing it, and then converting it back to string. Okay, it's fairly simple, I guess. So now character at I minus 1, it's equal to j minus 1. Okay, if both of them are equal, what we do, we do is I and j, dpij is equals to dp of I minus 1 and j minus 1 plus 1. Okay, so it's all LCS code. If you don't understand LCS, it's going to be impossible for you to understand. Okay, so I'm just writing LCS code. It's nothing else is there. Okay, I've just reversed it and then I'm finding LCS between them. Okay, it's that simple. Now let's do else code. Now else you have two cases, right? You have two cases. Either you move in string s1, or you move in string s2. That's the two cases there is. Okay, if you move in string s1, it will be like this: dp of I minus 1 j, and other cases dp of I j minus 1. Okay, fairly simple. And what we have to do, we have to maximize it, right? So we just take a max of them. Okay, a max, math dot max, and obviously I have to store it in dp of ij. Now I'm able to write this code very simple because I just remember LCS. I've done LCS so many times. It's using so many questions that I remember LCS code, and you should too. Okay, a lot of questions use LCS directly. just like this. It's a very famous question and it just uses LCS directly. All you have to do is think about it, that if you reverse it and then find LCS, it's actually LPS, right? Longest palindromic subsequence. Because when you reverse it and it's still common, that means uh, if you write it straight or if you write it in the reverse order, it's the same thing. So that's how you get um, uh, like longest palindromic subsequence. So I think till here it's okay. Okay, anything missing? It seems okay. DPF and comma N. Okay, let's see. And it should work just fine. We'll see if we have any issues. Oh, sorry. Uh, what it says? Mm, what have I done? Yeah, I think the rest is okay. What's wrong? Oh yeah. Okay, so after solving some uselessly stupid bugs, the answer is correct. Okay, so just recap what we have done. It's fairly simple. All of this is just LCS. So all I did was find LCS between S and reverse of that string. And why I did that? It's fairly simple. When you look at this, right, and you reverse it, okay, the longest common subsequence is out to be palindromic, right? Because it's common, it's same, and it's same after you have reversed it, right? So just by sheer logic, it's palindromic, and you have found the longest common, right? So it's longest palindromic subsequence. Okay, so this is just one application of LCS. LCS LCS is probably one of the most asked topics in DP. Just so it's just a general tip for DP. Just practice your basic problems: LCS, LICS, MCM, matrician multiplication, both types of knapsack, 01 and knapsack, and unbounded knapsack. So just practice these basic problems. There are a few more, right? And if you practice them enough times, and you get to see the trend that most of the medium questions can be just broken down or converted into one of these standard problems. Okay, so I hope you understand this. Thank you so much.